Hello everyone. We are officially live again for our third time together. We are doing our BJC, BGCSE, or any exam prep time, specifically in the area of mathematics. And we started our journey last Sunday on the 4th, and we are going to be meeting every Sunday and Tuesdays at 5 o'clock for the month of February only, all right? So this is going to be an opportunity for us to come together and get some tools to help improve our grades for now and even for the future, all right? And even give some extra tips or reteach some concepts that we've learned that maybe we didn't understand initially, and another opportunity to kind of get a good grasp on it, all right? So we are going to get started because we have a lot to cover and not a lot of time. So my name is Ms. Nelson, for those of you who do not know me, and let's get into it, all right? So you can let me know where you're tuning in from, and you can say the name of your school or whatever it might be, island, and I'm excited for you to be here, and I'm excited to see and hear your stories of how you're going to do well, how you're improving your grades, and even if you might struggle at this very time, just know that struggle is not going to be in your future. It's not. All right, so here's my disclaimer, and I have to say it every time so that you're aware. All right, so it says here, the information shared is solely for educational purposes. It is up to the discretion of the student how he or she chooses to use this information. In other words, I can just give you the ball, I can give you tips on how to use it, but it's your decision on how you're going to use that information, okay? I can't force you to get an A, although it would be cool if I could, but I know you can. And if you have not been getting a string of A's or have been succeeding the way you wanted to, now is not impossible to start here, all right? It's actually a beautiful time. So here's our opening activity. We have an open activity every time we meet. And how this is going to work is this. I'm going to show you a picture, an image, and I want you to spend some time looking at the image and looking at all the things that are going on in the image, all right? And as you're watching the image, I'm going to be telling you a story. So I'm going to need you to be looking and listening all at the same time. And then I have some questions, some follow-up questions, excuse me, to the image and the story that I'm going to read. All right, so are you ready? I think that we're going to go into it now. Here we go. So here is our image, and I'm going to read you a story. Now, I know you're like, it's not bedtime. You know, we don't do this at our age, but pay attention, okay? My story is about the little red truck, okay? The little red truck had 4 friends. One friend was a bulldozer, and she spent the day moving debris from one side of the green polka dot bridge to another. His second friend, whose name was Sam, was a fire truck, and he spent his days helping to deliver air fryers around the town. Some days, the owner of the little blue truck would spend his afternoons at Loppeyes because he enjoyed the taste of the chicken sandwich. While sitting in the parking lot one day, the little red truck's third friend, Harriet the helicopter, flew overhead wearing a purple dress. That must be an interesting sight. She was always very kind to the little yellow truck. After lunch, the owner of the little red truck would drive him to the house, and he would spend the rest of his time under the cool peanut tree with his best friend of all, the lavender school bus. Okay? What a story. What a story. Now, I'm going to go ahead and look at the questions, and let's see how much you can remember from either the story, the picture, or both to answer the questions, all right? How many swans were in the pond? Anybody? You can say it out loud, you can type it in chat, think about it. Do you remember? Were there swans in the pond? I wonder. What color was the bunny rabbit? Did any of you even see a bunny rabbit? Did you see a bunny rabbit? Did you notice the elf above the lamppost? What pattern is on the green dress? Some of you are like, what green dress now? Is there something strange about the fruit tree or the fruit that grow on the tree? And how many children were climbing the tree? This is a good question. Some of you may have remembered all of these details, and some of you don't remember a clue of any of them. You're like, okay, what tree are we talking about, right? Now let's take a look at the picture one more time. Okay, now what you'll notice is now you know what to pay attention to because, well, you know the questions. Before you didn't have the questions. All right, now what about the story? What questions can come about from the story that we listen to? So it says, name the friends of the little red truck. What did the fire truck spend his day doing? Did you hear the answer to that? Describe the bridge in the story. Some of you are like, there was a bridge? Yeah, there was a bridge in the story. How many times did the color of the truck change? It did change a few times. What color was the dress worn by Harriet? How many different colored trucks are in the story? And do peanuts grow on trees? That's a good question. The answer is no, they don't. Most of the story, everything's made up, right? Helicopters don't wear dresses. They don't wear clothes at all, right? They're vehicles, flying vehicle. Nevertheless, what is the point of all of this? And I'm going to show you the story as well, so that way you can look through the story and maybe you'll find some of the answers to those questions while I'm speaking to you. But what you'll notice is it's very difficult. It's kind of difficult to focus on things on a picture and then listen to you tell a story that are so unrelated all at the same time. It's difficult to do so. And why? It's just because that's how our brain works. It's very difficult for your brain to focus on a million things at the same time. All right. So what do we get from this? What you focus on grows. So what does that mean? When you go into a classroom and you're going to learn something, if your attention is divided, it's going to be extremely difficult to actually focus, right? If you have people talking in the background, if you're on your phone, right? If you're checking Facebook or things that are super unrelated, it's different if they're exactly related because it kind of reinforces certain concepts. But if they're absolutely unrelated, right? Like the little red truck and the park with the kids playing on it, then it's going to be very difficult to link those information together and actually remember it and retain it and apply it later. So I want your attention. Now, if you feel like I cannot study for more than 20 minutes, then what you're going to do is for the first 20 minutes, you're going to focus on me. You're going to focus on whatever goals you have to study. You're going to focus on math and history and Spanish. Then you're going to take a break. All right? And then once you take your break, you're going to go take a walk, get some Kool-Aid or something, get something to eat, do something to energize yourself. And then you're going to come back after the next 5 to 10 minutes, something like that, of a break. You're going to come back for the next 20 minutes. All right, but whenever you find yourself losing focus, you either need to do something to help you to regain that focus or take a little break and come on back so we can be effective learners and we can see those, the things we're learning reflect in our grades, all right? So let's get into it. What did we talk about so far? Well, where are we? What have we accomplished? So last week we talked a lot about expressions. We talked about the parts of expressions, simplifying expressions, writing expressions from word problems. So we did a lot, right? And we're going to get into more word problems because word problems are really the bigger part of most of these examinations. But I want to talk to you about how do we solve equations, all right? So we're going to get more in depth on equations during our time together. And that way, when we get back to the word problems, we have the little steps or the little things that we need to help us to solve them once we convert them from word problems into actual equations, all right? So let's get started. So we did our opening exercise, which is about focus. What we focus on grows, which also means if you're focusing on negativity and failure, then that's going to be the bigger part of the picture for you. But if you're focusing on a success, on conquering things, on doing well, then those things are going to grow over time, all right? Then we're going to reteach, which is what we're going to get into. We're going to reteach some concepts you've probably seen and heard before, specifically today about equations. Or it might be something you've never seen before, and that's okay, right? Everyone starts somewhere. Something you ain't never heard before, and if it's something that you've never heard before, just be mindful. I want you to take really good notes. And the beautiful thing about technology is you can watch this video over and over and over again, all right, until you get it down. And then we have an exam prep tip for you, and this prep tip is not just for exams. Like, you don't have to wait until the exam comes up for you to apply it. You can literally do it today, and you'll see progress, and the more you do it, the more it becomes a habit, okay? And you'll do well. You'll remember it. It'll have an impact on your life now. And then some resources, all right? When I say resource, usually what happens is after the video is all done, I'll link a worksheet in the description box. And usually that worksheet is on our YouTube page, not on the Facebook pages. So go to our YouTube page at the @ reteach learning, all right? And you can go there and you'll see the link for any of the worksheets in the description box of the videos, all right? So why did I say we're going to have a lot to cover today? Well, we are going to cover solving equations, all right? So we're going to go through the basics of equations, solving one-step equations, multi-step equations, and equations with variables on both sides. That was a mouthful. That was a mouthful. All right, so if you need to pause, get a break, get some water, you can do that. And then we're going to get into it, all right? Gonna get into it. All right, so far, our previous sessions, we talked about expressions. And the big difference between expressions and equations is that an equation is two equivalent expressions. What do I mean? What do I mean? Well, equivalent, that word just pretty much means equal, all right? And usually on one side of the equal sign, there is an expression over here. Just like in all of these examples, there's an expression on one side. And it is equal or equivalent to an expression on the other side. Okay, and these expressions can look any number of ways, all right, on either side of the equal sign. But the entire thing, once you have an equal sign smacked in there, that is an equation, all right? So how do we solve these? Okay, how do we solve these things? Well, I want to take you back so that you can understand what these equations are. Why do we do this? Where is this coming from? Am I going to apply this in my everyday life? Well, let's take a look, right? The concepts, absolutely, we apply all the time. So how do we do this? Well, I want you to imagine that you and a friend, or you and your worst enemy, whichever one works for you, are given $20 apiece from your mother. Now, some of you might be like, why would my mother give my worst enemy $20? Well, you know, she's just a really good mom. Or, you know, whatever. She just feels like it. So she gives both of you $20. And I'm sure, or your sibling, right? I'm sure if she gave your sibling or someone else more than you, you would be like, Mom, well, that's not equal. If you give me 20, you have to give that person 20, right? You want to have equal between the two of you. That's good, right? That's what we want. When we are talking about equations, we're talking about two equivalent, two equal expressions, all right? Even though they don't look equal, they are. That's what we're telling you up front, that you're getting $20 and your friend's getting $20. Okay, no problem. Well, let's play around with these $20 for a second, all right? So let's play around with it. So if I tell you up front, what you get and what that person get is always going to be equal. That's the point. That's the bottom line. Then I come back to you later and I say, hey, I think I gave you too much money, son or daughter. I need $5 back, okay? So I take $5 from you. How much would you have? If you had $20 and I took $5 from you, well, you'll have $15 now at this point. But we have a problem. Well, if it's an equation, they both have to be equal on both sides. So if I take $5 from you, then you should say, well, you have to take $5 from so-and-so as well, because that's the only way we're going to be equal, right? Yeah, it would make sense. So I'm going to have to take $5 from the other side as well, and I'll get 15, all right? Now keep in mind, whatever I do on one side of my equal sign, I have to do it on the other side of my equal sign as well. That's the only way they'll be actually equal, right? This also applies if I'm adding, right? Let's say I decided to give your worst enemy an extra $5. And that's going to be $25. Well, you should expect that if I'm telling you that you're getting the same treatment, that I'm also going to give $5 to you as well. So that's going to be $25, right? Whatever I do on one side, I'm going to do on the opposite side, right? Now, addition, subtraction, got it. What about multiplication and division? Well, let's see. If I take that $20 and I decide that, okay, I got to cut that in half. I need you to give me half of the money back that I took from you. Well, once again, if the idea is that we have to be equal, then I have to also cut in half the $20 I gave to your worst enemy over there on Sunday morning. Yeah? Yeah, I would. That's the only way it's going to work. This equality works is if what I do for Johnny, I do for Sally. Whatever I do for John, I do for Janita. Right? When you're like out of names. But yeah, you have to be fair. And so that's the idea. Now, I talked about addition and subtraction and division, but it also works for multiplication as well. If I said to you, okay, or I said to John that I'm going to give you twice as much money, then if we're talking about equality again, I have to do the same thing to you. I have to give you twice as much, right? That's the only way equality works. And so this rule that we see is what we call the rule of equality. Whatever I do for John, I have to do for Sally. That's the only way this works. That's the only way it is an actual equation. All right? So now let's go even deeper. Let's say my equation starts to look like this. Now what I want you to notice is that the 20 stayed the same, right, on the left-hand side. But what I did was I just simply rewrote the right-hand side as 5 plus 15. They're still the same, but what it's saying is maybe I gave you $20 up front, but let's say I only had a $5 bill and maybe 15 ones or something. So I gave you both $20 in total. It's just that I had to use different bills to represent the money because that's all I had in my pocket. So now that we're here, notice that the left-hand side is still the same as the right-hand side. Okay. I hope I'm not losing you. Okay. But yeah, it's still the same. It's rewritten differently, but it's still the same. That's just what I want you to get. They're still the same. They're still equal. Well, what happens if I introduce a variable now, an unknown, an x? Well, notice that we already know that the x would have to be 5, right? The only way that this would be equal is if x is equal to 5, because the only number plus 15 that would give me 20 is 5. So x has to be equal to 5. Now, you can guess that answer, and guessing works sometimes. But what happens when the equation looks like this? You gonna guess, ma'am? No, you might, but if you're lucky or something, you might get the answer right the first time. But for the most part, the more complex the equation becomes, then you get to a place where you're like, okay, I need a system that works regardless of what my equation looks like, that I can follow every single time, all right? So it's not as easy to count when the equation gets more complicated. It's just not. But what system can I use? Well, I'm going to show you 3 steps. And these 3 steps have little parts to it, but I want you to go ahead and either take a screenshot or write them down or something of that sort. But go ahead and do that, all right? So let's take a look at the steps. There's 3 steps to this, and this will work the whole time we're together, whether we're dealing with single-step equations, 2-step or multi-step equations, or equations with variables on both sides, all right? These 3 steps will work every time. Now, I'm going to go ahead and explain each step to you so it makes more sense. I can't pause the video or literally stay on this one screen the whole time so you can write it down. So take a screenshot or just come back to a little bit later but I want you to pay attention to me explaining each one of them. So that way it makes sense when you apply them. And we're going to spend most of our time applying these 3 steps to multiple different types of equations during our time together. All right. So the first step, can I simplify on either side of the equal sign? All right, that's the question. Can I simplify on either side of the equal sign? Now, as I'm talking about these steps, if it's like going over your head a little bit, it's okay, okay? I'm just mentioning the steps now, and then we're gonna kind of put them in practice. And with most math, if not all of it, practicing is what makes this thing make sense. Okay, if you're just going to write some stuff down in your book and you're not going to practice it, then that's why it looks like gibberish after a couple of days and you finally go back, because we're not practicing. So, can I simplify on either side of the equal sign? And how do I know? Well, look for those little keys like, can I use distributive property? Can I combine like terms? Or can I use PEMDAS, right? PEMDAS was something that we used to combine like terms or, to simplify expressions. The next step is to identify the goal. Now, why do I always put the goal in there? Because most times when students finish step 1, I hear them say, I'm not sure what to do next. I'm not sure. And it's fair. Sometimes we're just not sure. And so I have 3 questions I want you to ask yourself to help you to get unstuck. And it has to do with the goal that you're trying to accomplish. And then the last step is undo the operations using PEMDAS in reverse. This is the 3rd step. We're not going to do this 3rd step first, okay? We're going to do it 3rd after we've made sure we've done the first 2 steps. Now, some of you, this 3rd step might look like I've never seen that before, and that's okay. Let's practice it. Let's do our thing, and we'll get through it together, all right? Now, let us see. Why do we simplify? This is me explaining each step. Why are we doing this? Well, if I came to you and I gave you a box, and I go over there and give your arch enemy 3 boxes, and then I tell you, hey, they're the same gifts. I mean, this person has the same gift, it's just they're separated into 3 different boxes, but you have the same gift as that person. Well, you look at the box and let's say you don't really know me that well, so you might be like, I don't trust you. I need him to open his gifts to see what is actually in those boxes. Well, then, they'll open up the boxes and they'll see. But for the most part, when we talk about simplifying, that's the concept. On both people are getting the same gift, but sometimes it's not easy to see it. Sometimes it's a little bit more complicated, and it requires simplifying. So it might require him to open all 3 of his gifts. You open your gift, and then you make sure you compare what each of you have. That's an example of simplifying in the real world, and that's what we do in math as well. We want to break down each side individually first just to see, okay, what is it that we have, so we don't have too much crazy stuff going on that makes it hard to see what the steps are, all right? So that's why we simplify. Next thing, why is the goal important? The goal, like I said, is sometimes we get stuck, and that is a common thing across the board. Sometimes when you do steps from one step to the other, you get stuck and you wonder, how do I get unstuck? Well, here are the 3 questions you're going to ask yourself. When you get stuck doing an equation, the first thing you need to ask yourself, what is my goal? All right? I had to breathe. So, what is my goal? Your goal is always, in an equation, is always to get the variable, and a lot of times you'll see it's an x, but it doesn't have to be an x. It could be any letter of the alphabet, but x is just very popular. X on one side of the equal sign by itself and some answer on the other side, all right? That's going to be your goal in an equation. That needs to be very clear. We're talking about equations, not expressions. So in equation, our goal is to get the x on one side of the equal sign all by itself. Perfect. So then the next question is, what is in the way? And what do I mean? A lot of times when you have an equation, you'll have a situation where it looks like this. 2x is equal to 7. And people will say, I don't know what to do. I'm stuck. Well, your goal, once again, is to get the x by itself. What is in the way? Well, whatever's on the same side as the x is in the way, right? So that's going to be the 2. That 2 is in the way. So I need to get rid of the 2. If you're thinking I need to get rid of the 7, no, well, the 7 is not on the same side of the equal sign as the x's. So the 7 doesn't matter right now. What does matter is the 2, because the 2 is preventing me from getting to my goal. Okay, cool. I can figure that out. All right, got the 2. What do I do with it? Well, the question is, how do I undo the operation I see? Well, whenever, and this is something we said in another session, whenever we see a number that's attached to a variable, the way this is, like there's no operation between them, written between them specifically. So the assumed operation is multiplication. So I'm multiplying 2 by x. So how do I undo a multiplication by 2? Well, if I'm undoing it or reversing it, I need to divide by 2. Okay, so these are just 3 questions you can ask yourself just to get unstuck. Now, what these 3 questions will not necessarily do is take you directly to the answer, but it will just help your brain to start working to say, oh, okay, I got it from here. Like, I'm good. Thanks, I got it, So just to get you unstuck, and some of you, that's what you need. You just need to get unstuck from where you are and get your brain kind of ticking in the right direction, and you can take it from there to the answer, and that's really good. Some of us need a little bit more help, and that's okay. That's why we're going to spend some time practicing so you can see where we're going. And then lastly, PEMDAS in reverse. I've never heard that before. Well, you've heard of PEMDAS, some of you not, but let me explain what's happening. Once we get to this 3rd step, when we're dealing with equations, once we've simplified everything and we figure out what our goal is, when we're dealing with equations, the thing about equations is that we're trying to figure out the piece of the puzzle that's missing. Just like earlier when we had the equation 20 equals x plus 15, we know the answer was supposed to be 20, but the x is the missing piece of the puzzle. What does that x need to be so that when I add it to 15, I get 20 as my answer? Well, in order to figure out the missing piece of the puzzle when it comes to equations, we move back in reverse. We undo everything we did so that we can figure out what's the missing piece of the puzzle. all right? And so this is where we introduce the concept of doing PEMDAS in reverse. So you know PEMDAS, the P is for parentheses or groups, and pretty much anything in a group. The E is for exponents, the M is for multiplication, D division, A addition, S subtraction. So we're going to tackle those. We do PEMDAS when we're simplifying expressions individually, just like in the first step when we're looking at individual sides of our equation. But then when we're looking at the entire equation and trying to get the x by itself, then we're going to do PEMDAS in reverse. So we're going to practice that. I said it. Now let's practice it, okay? All right, here we go. What is our goal? So let's do all of our steps, okay? So our first step is, can I simplify? Can I simplify on either side of the equal sign? So for now, I'm going to pretend like my equal sign is a wall. I'm just writing here for just teaching purposes. You do not have to draw a wall on your book. But imagine it's a wall, and I'm just going to consider one side at a time. And this is where I'm going to simplify. So looking at the left-hand side, where it says x plus 5, can I simplify? In other words, can I combine like terms? No. The x and the 15 are not like terms, okay? And why is that the case? Well, the x is a variable of x, and the 15 does not have a variable of x, so they're not like terms. I can't use distributive property. There are no parentheses. There's no multiplication happening. That actually can happen, so I'm done with that. And there's no way I can use PEMDAS at this point. So on the left-hand side, there's no simplifying. Like, I'm done. I don't have to simplify. So perfect. Now let's look at the right-hand side. The right-hand side is 20. Just 20, in your face kind of 20, okay? And it just so happens that there's nothing that I can do with that either. All right, so my step 1 is done. Isn't that cool? We just finished step 1. We didn't have to do anything except for just compare and see what we had with us, all right? The next step is to identify our goal. Our goal is to get to the x. All right, now remember those 3 questions that we asked to get unstuck? Okay, we know what our goal is. What's in the way? What's preventing us from getting the x on that side all by itself? Well, what's in the way is this 15, specifically a plus 15 or a positive 15, plus 15, right? Now, if your thought was, oh, the 20, I need to get rid of the 20, well, notice the 20 is on the opposite side of the equal sign. So if it's on the opposite side, it's not in my way, it's not doing anything to me. I can leave the 20 alone. Let's move everything away from the x. Now, so I have a plus 15. So the next question, a part of that unstuck slide, was how can I undo the operation that I see? Well, how do I undo an addition of $15? In other words, if I gave you $15, that's like plus 15. How do I undo that? How do I reverse that? I reverse it by subtracting or taking it away from you. So I'm going to subtract 15. All right, think about that for a second. And then I want you to think about that example we talked about earlier with someone giving you and your arch enemy money, a $20 bill. Well, if I went ahead and took $15 from you, you would say, wait a minute, if we're equal, you have to take $15 from this brother over here too. Otherwise, it's not equal. So equations, the rule of equality applies. So if I take 15 from the left-hand side, I must also take 15 from the right-hand side as well. All right, whatever I do, even if I didn't do it right, whatever I do on the left side, I must do on the right side. All right, so here we go. What does my next line look like? Well, the x, I did not do anything with the x, so I'm going to go ahead and just bring that thing down to the next line. Now, a plus 15 or a positive 15 minus 15 will give me a 0. All right. So that's gone, which was my goal. My goal was to get rid of it or to undo it. So x is equal to, what's 20 minus 15? Well, that's going to give us a 5. All right. So what does that mean? That means that x is equal to 5. All right. Now, if you wanted to check your answer, what you'll do is you'll take a look at the original question, which is x plus 15 is equal to 20. And what you need to do is, where you see an x, you're going to substitute that for 5. So it'll be 5 plus 15 is equal to 20. And is that correct? Yes, it is. And that's how you would check your answer if you wanted to check your answer. All right? So that's how we would do the 3 steps. Now, the question is, well, I didn't do PEMDAS in reverse. Well, notice that we only had one operation. In other words, we just had addition. So PEMDAS in reverse is really good when we're dealing with multiple operations. But notice we were able to get rid of get to our answer without even getting to the third step, which is really cool, right? All right, let's keep going. Now we had addition. What happens when I'm subtracting something from x? Okay, let's take a look. Same process. Ignore the equal sign, or pretend like this is a wall for a second. I wouldn't say ignore it, but just pretend like it's a wall. And let's see, can we simplify on either side of our equal sign first? Can I do that? Well, if I look at the left-hand side, I have x minus 5. Now, if I'm subtracting terms, there's only one operation, so I have to subtract. If I'm subtracting terms, they have to be alike. Are they alike? Well, the answer is no, they're not alike. Why? Well, because this is a variable of x, and this is just a constant. So they're not going to be alike. The 5 would need to have the same variable for it to even be considered as like terms. So that's not the case. So they're not alike. So I can't simplify there. And then 20 is just 20, in your face kind of 20. So, you're done with that. You don't have to worry about it. So now that I finished my first step, identify my goal. My goal is to get this x. All right, now that those 3 questions about being unstuck, I know what my goal is. The question is, what is in the way? What's preventing me from getting to my goal? Well, what's preventing me is the minus 5. Another way you can think about it is negative 5. It's okay, same. All right. So how do I undo a subtraction of 5? How do I reverse that? Well, the opposite of subtracting 5 is adding 5. Okay, so I'm going to add 5 to itself, so plus 5. And once again, the rule of equality applies. Whatever I do for you, I have to do for someone else. That's what equality looks like. So plus 5. All right, there we go. Now let's do the math. Let's do the math. So x comes down. Now this applies to any situation. Whenever you do not tackle a term or do anything with a term, you can just bring it back down. You can literally just rewrite it because you haven't touched it yet. So the x comes down. Negative 5 plus 5 is going to give me a 0. And then 20 plus 5 is 25. And so here we go. X is equal to 25 is my answer. Awesome. So we're able to get through this using the first 2 steps. Haven't gone to the third step yet, but we will, right? Because these are simpler equations. These are literally just one-step equations. Let's take a look at another example. Ooh, this looks a little different than the last one. What's different? What would you say is different about this one? Well, what's different is you have the number out front and the x follows after that, right? Some people do get confused when the x is in a different position. But let's tackle this for a second and take a look at what we have, all right? First of all, step 1, simplifying. Can I simplify? Can I simplify? Once again, we're going to pretend like this is a little wall. And the reason I'm saying it's a wall is because I want you to notice that I'm only talking about the left-hand side of that wall. Not both, just one side at a time. So on the left-hand side of this wall, I have negative 5 plus x. All right, can they be simplified? Well, what they're asking me to do on the left-hand side is to add them. Well, in order to add 2 terms, they have to be like terms to do that, and they are not. All right. Now, if you haven't caught on to why they're not as yet, you can go back and watch our second session, and we'll talk about. And it talks about like terms at that point. And now let's take a look at the right-hand side. On the right-hand side, we just have 20. Once again, in your face kind of 20, and you can't do anything with that, guys. So we're done with the first step. Our second step is, what is our goal? Well, here's our goal. Our goal is to get to the x. We want to get to the variable. And once again, that x is just a letter. It can be any letter in the alphabet. It does not matter. So what is in the way? What is in the way? Well, what's preventing me from getting to my goal? I need to consider everything that's on the same side as the x, on the same side of the equal sign. And I have a negative 5 sitting here. Okay, no problem. Well, what I want you to keep in mind is whenever you have a negative number out front, or even a positive number, it doesn't really matter, but it's the same as saying 0 minus 5, or if it was positive, 0 plus 5, or whatever the number or term is, same thing. So why am I saying that? Well, because our next piece when it talks about getting unstuck is, how do I undo the operation I see? Well, I see a minus 5 or negative 5. So I'm going to undo that by adding 5. All right, now the 0, you don't have to worry about it. I just put it there so you can notice that it's like I'm just adding 0. I just have a 0 in front, okay? Some people say change side, change sign. If that works for you, work it, you know? No love lost in that regard. All right, so let's go ahead and do the math. -5 plus 5 is going to be 0, all right? The x, I haven't touched it yet, so that stays there. And then 20 plus 5 is 25. All right, good. So my final answer is 25. All right, so you can look back at that again. Let's look at another example. So we talked about addition, we talked about subtraction, and then what happens if the terms change position, right? This is a good example of that. But what happens when I have this? What do? You can pause here. You can try it on your own and then keep going, all right? What do we do? Let's go through the steps. Same 3 steps every time. Can I simplify? Well, if I take a look at the right-hand side and the left-hand side individually, as if this is a little wall right here, 20 is just 20, in your face kind of 20. And then 2x is just 2x. 2 times x, that's it. It is what it is. No way to simplify that any further. So now our second step is our goal. Our goal is to get to the x, all right? So those 3 questions to get unstuck. You know what your goal is. What's in the way? Well, the 20 is not on the same side of the equal sign as the x is, so the 20 can't be in my way, but there is a 2 that's sitting here, all right? Perfect. Now the question is, how do I undo that? Well, here is where sometimes students might get confused. They might say, oh, I see a positive 2, I'm going to subtract 2. And that's not what's happening. What operation do you see? Look at it very carefully. When you have a number, which is going to be a coefficient in this case, that's attached to a variable, and there's no explicit operation given, like for example, you don't see a minus sign between them, you don't see an addition sign between them, you also don't see division, then the assumed operation is multiplication. So MUL, I'm just going to put MULTI. That's my shortcut to multiply, okay? So if the operation is multiplication, how do I undo that? What's the opposite of multiplication? Well, division is the opposite of multiplication. And what am I dividing by? I am dividing by the thing that I'm multiplying by, which is the 2. Now keep in mind, you're not multiplying or dividing by 2x, because you're not trying to move the x. You're trying to move the 2, because that's the problem. You're trying to get rid of the problem. The x is not the problem right now. So you're only dividing by whatever is being multiplied by the x, all right? And whatever I do on one side, I have to do on the other side. Whatever I do for you, I have to do for someone else if they are equal, if you're both equal. So here we go. 2 divided by 2 is 1. So I end up with 1x, or just x. And then 20 divided by 2 is 10. There you go. And you can check your answer the same way we checked our answers previously. The original question says 2x is equal to 20. And we already established that the operation there is multiplication. So what this means is 2 times x, which in our answer is 10, is that equal to 20? Well, the answer is yes, it is. So that's a way to check your answer, all right? Now we did addition, subtraction, we're doing multiplication by a positive number. What happens when it's negative? Same concept, right? Can I simplify? You do that answer. You probably can look and see, okay, I can't simplify. I can see I can't simplify by now. So I can't simplify. Now, what's my goal? I want to get to the x, all right? So the 3 questions, how do I get unstuck? I know what my goal is. What's in the way of that happening? Well, I have a -2 sitting here, all right? Now the question is, how do I undo the operations that I see? Well, this is also where sometimes it can be confusing, because you might see a negative sign and say, oh, I can just add 2. Now, this is where I'm going to tell you to pause, hold your horses, okay? Is the subtraction sign between the 2 and the x? Well, no, it's not. It's in the front of the 2. So what that really means is that I'm multiplying a -2 by an x. So how do I undo a multiplication of -2? Well, I divide. Now, keep in mind, I'm only changing the operation, not the sign. I'm changing the operation. So instead of multiplication, it becomes division by whatever it is that's being multiplied by the x. All right? So the sign does not change. when we're talking about multiplication division, what we're talking about is the changing of the operation. And I just want to say this, when I say operation, I'm talking about that PEMDAS situation, all right? Whatever the opposite is addition, the opposite of addition is subtraction, the opposite of multiplication is division, and so forth, all right? And then once again, whatever I do for you, I must do for others. So I must go ahead and divide by 2 on the negative 2 on the right-hand side as well. All right, so let's do the math. Negative 2 divided by negative 2, so I'm dividing by 2 negatives. That's going to give me a positive answer. So that's going to be x, positive x, or positive 1x if you want to put that in there. And then a positive 20 divided by a negative 2 will give me a negative 10. All right, and you are welcome to check your answer as well. Now we did addition, subtraction, multiplication. Now let's take a look at division, all right? Does this work in division? Yes, it does. You can try it on your own if you would like to. So here we go. Can we simplify on either side? The answer is no. And one of the reasons, we just have 20 over here. 20 is 20. And then x divided by 2. Well, there are no, if we had the same variable in both the numerator and denominator, then we can simplify a little bit. But in this case, I don't have a variable in my denominator. I just have a constant down there. So I can't simplify. So next thing is, what is my goal? Well, I need to get to this x right here. Now notice the x is in the numerator. Okay. So what's in the way? Well, I have a division here. I have a 2 that's there, and the operation that's happening is I'm dividing by 2. Another way to look at this is as if I'm multiplying by a half. Excuse me. But right now we're just going to look at it for what it is. I'm dividing by 2. And how do I undo a division by 2? Well, I need to multiply by 2. Okay, now notice that 2 goes into the numerator, all right, multiplying by 2. And I must do the same thing on the left-hand side. So 2 times 20 is 40, and that is equal to, on the right-hand side, notice the 2 in the numerator cancels with the 2 in the denominator, and I'm left with x. All right, now the question is, am I done? Have I met my goal? The x is on the other side. What do I do? Well, the question is, have I gotten the x on one side of the equal sign all by itself? And if the answer is yes, then you're done. It doesn't matter which way they appear. So 40 equals x is the same as saying x is equal to 40. All right, there you go. So we've tackled situations where there's only one operation, right? And what we've noticed is we're able to do, just by the first 2 steps alone, I was able to get my answer without even getting to the third step. But is the third step important? Well, yeah, it is, and we'll see it in the next few slides. Can I use these steps when there are more than one operation? And that's where that third step is really key. And the reason I want you to remember it is because you don't know what you're going to see on your exam. You don't know. So it's good to be aware of what you're dealing with. So let's take a look. First step, can I simplify? Now, I'm saying the same thing over and over and over again, even though you can see it on your screen and read it for yourself. But the more you hear these things, the more you practice it, the more you see it and read it, it literally just becomes a part of your makeup in a sense. All right. So I'm hoping that when you go to bed tonight, you'll hear me asking these questions. Can I simplify? Okay. All right, let's keep going. Can I simplify? Take a look at both sides and pretend like that equal sign is a wall, all right? So we're not comparing across the equal sign. We're just comparing one side by itself and then the other side separately. So I take a look at the 2x and the minus 5. They are not like terms, so I can't subtract them. And then the 15 on the right-hand side is simply just in your face, 15. So can't do anything with that. So I'm done with step number 1. Now step number 2 says I need to remember my goal. My goal is to be able to get the x all by itself on the whatever side I choose. Right now it's on the left-hand side. So now the question is, what's in the way? Well, there are 2 things in the way of that. The minus 5 here and then the 2, but just remember this is multiplication. Multiply. Okay, so we have 2 operations. We have subtraction and we have multiplication. So now this is where we have the question, which is the third thing. How do I undo these? Well, let's go to our third step. Our third step, it says undo the operation using PEMDAS in reverse. So if I'm using PEMDAS in reverse, that means that I'm going to be subtracting before I take care of the multiplication. All right, so let's go ahead and do that. So we have a subtracting, subtract 5. And how do I undo a subtraction of 5? How do I reverse a subtraction? I have to add it. So I'm adding 5 to the left-hand side, and what I do on one side, I must do on the other. So I'm going to add 5 as well on the right-hand side. So let's do the math. The 2x comes down. I didn't touch that guy. Negative 5 plus 5 is 0. The equal sign is just the equal sign. You don't have to know the equal sign. Some people like to line up their equal signs. You can too. It's okay. And then 15 plus 5 is 20. All right. So here we are. Now we have to remember, what is our goal? Okay. We always come back to it. What's our goal? What's my goal? What's my goal? Whenever I take a step, if I still have something where my goal is not met, I have to consider what I need to do next. All right. So my goal is still to get the x. All right. What's in the way? Well, this 2 is in my way. And what's the operation? Well, I'm multiplying a 2 by x. I'm not adding it. I'm not subtracting it. I'm not dividing it. I'm multiplying it by x. So how do I undo a multiplication of 2? Well, to undo it, I have to divide, because the opposite of multiplication is division. So I need to divide the 2x. So I'm going to divide. And what am I dividing by? I'm dividing by 2. I'm dividing by the thing that I want to get rid of. All right? So with that being said, we have division by 2 on the left-hand side and division by 2 on the right-hand side. Go ahead and try this and get the answer on your own and see where you end up, okay? So we have 2x divided by itself, which is going to be 2x divided by 2, which is going to give me x. And then 20 divided by 2, which is going to give me 10. All right, so that's where we are. Okay, so hold for me one moment, okay? Okay, here we go. Okay, so let me know if you can hear me still, okay? All right, so we have x is equal to 10. And that's our answer. Now you can check this if you want to, and that is good. Let's go ahead and go to the next question. When I have 2 operations, okay? So same thing, same questions, okay? Or same steps that we're going to take. We are going to do 6 is equal to, let me go ahead and, all right, so 6 is equal to x over 2 plus 3. Our first step is we're going to ask ourselves, can I simplify? Well, yes, well, let's see. We're going to ignore or use the equal sign as if it's simply a wall. On the left-hand side, I just have a 6, so there's nothing I can do with that 6. So I'm going to have to leave it all over there by itself. And then on the right-hand side, I have x divided by 2 plus 3. Now, the way I know if I can simplify is, can I use PEMDAS on the right-hand side at any point, right? Okay, and the answer is no, I can't use PEMDAS. So now that the left-hand side and the right-hand side cannot be simplified, let's take a look at our goal, all right? Our goal is to get to the x, okay? So how do I get to the x? Well, we're going to ask ourselves, okay, if our goal is to get to the x, what's in the way? What's preventing me from getting the x by itself? Well, the 2 is preventing me from getting the x by itself, as well as the 3. So if that is the case, let's identify what operations we see happening, right? That's our next step in terms of the how do we get unstuck. All right, so we have, okay, so we have addition and we have division, all right? So how do we tackle them? Which one do we do first? Which one do we do second? Remember, in this case, we're doing PEMDAS in reverse, all right? At this point, we can't simplify any side. So now we're doing PEMDAS in reverse. And it just so happens that addition, it takes preference over division when you're doing PEMDAS in reverse. So let's take care of that. So how do I undo an addition of 3? Well, I need to subtract 3. And whatever I do on one side, I must do on the other side as well. So minus 3. All right, so let's do that math right there. So 6 minus 3 is simply going to be 3, and that's equal to x over 2. And then 3 minus 3, that's going to give me a 0. All right, so that's where we are. All right, now our last and final step is this. What is my goal again? My goal is to get to the x. And the x is here, and the 2 is in the way. So how do I get rid of that 2? Well, I'm dividing by 2. How do I undo a division of 2? Well, I need to multiply by 2. So here we go. And we must do whatever we do on one side, we must do on the other side. So 2 times 3 is 6. And that's equal to the right-hand side. And notice that we have a 2 in our denominator and a 2 in our numerator. So they cancel each other out. And we're left with x. So 6 is equal to x. This is our final answer. All right? Okay, now, what about something like this? Does this apply? And the answer, once again, is yes, it does. But how do I look at something like this? Do I, if I remember correctly, Miss Nelson, I can't simplify on the left side. I can't simplify on the right side. My goal is to get the x by itself, okay? I see addition and I see division. So do I subtract 9 now? Good question. Well, here's a way I want you to consider this question. Notice that we have x plus 9. That entire group is being divided by 3. Literally, you have a numerator, x plus 9. That's a group. And that entire thing is being divided by 3. So remember, parentheses and groups, they mean the same thing, right? And so if you're going to do PEMDAS in reverse for this, parentheses comes after we tackle division, all right? So that's one way you can see this. So what does that mean? I'm going to tackle the 3, the division by 3, by multiplying by 3 first, and we must do it on both sides. Now I kind of want you to see this so that you understand that if I have a group or a few things and they all have the same denominator, like they're all being divided, then the numerator will be considered a group and everything in the denominator is going to be considered a group, all right? So we'll see more examples of that another time. But let's go ahead and do the math. So 3 divided by 3, they cancel each other out and they become 1. So I have x plus 9, and that is equal to 8 times 3, which is going to give me 24. All right. And if my camera goes out again, you can let me know, okay? All right. Now, next step, we have a subtraction of 9. Remember, our goal is to get the x by itself. The 9 is in the way. And we're adding 9, so we need to do the opposite, where we subtract 9. And the opposite, and whatever we do on one side, we must do on the other side as well. All right, so minus 9. Now let's do the math. The x comes down, and then 9 plus positive 9 minus 9 is going to give us 0. And then 24 minus 9 is going to be 15. All right, so this is our final answer. Okay, so it does work. It does work regardless of what it looks like. Just take your time. Now, if you've come across examples where it doesn't work, then there's other things you can consider. But specifically, when we're dealing with equations that look like the ones on the BJC and the BGCSE, this is a way that you can tackle them, all right? So with that being said, we were able to do solving equations, the basics, solving one-step equations, multi-step equations, but we didn't talk about equations with variables on both sides. We didn't talk about that. So let's take a look at it for a moment and go right ahead and finish this off, all right? A few more minutes, a few more minutes, and we'll be done, all right? Now remember, all of these questions are adaptations from the BGCSE, and one of the reasons I chose the BGCSE is because for the most part, these questions occur on both the BJC and the BGCSE, and you will solve them the exact same way, all right? Similarly, if you see these on the SAT, the process is still the same, all right? Now, let's take a look at this. Now, some students will panic at this point, and they'll say, oh my God, I have an X on both sides. What in the world do I do? How do I tackle a problem like this? Well, how you would do this is you would decide, well, go back and think about your goal for a second, all right? Consider your goal. Now, our goal is that we want to make sure we get the X on one side of the equal sign by itself. So we don't need to panic. All we need to do is decide which side of the equal sign do we want to put our X's, okay? And then you just move the X or eliminate it from one side and put it on the other side, all right? So what do I mean? Usually I kind of sometimes tell students to move the smallest X, but it really doesn't matter. It doesn't matter. It really doesn't. So let's say I wanted to move the 3X and just get all the X's on one side of the equal sign, all right? What I will note first is our first step is, can I simplify? I create a wall between the equal sign or at the equal sign. I take a look at the left-hand side by itself, 3X minus 7. If I'm going to subtract two terms, they have to be alike, and these two are not alike, so I can't subtract them, all right? Same thing on the right-hand side, 5X plus 4. They're not like terms, can't subtract them. Well, can't add them. All right, so I did my first step. I can skip that or move to the next one. What's my goal? My goal is to get the X on one side by itself. So this is where I just choose one of the X's, or I decide which side I want to move all the X's on. So let's say I decide I want to get rid of this 3X on the left-hand side. Now, keep in mind, I'm taking the entire 3X. I'm removing the entire 3X. I'm not separating the 3 from the X. If I was separating the 3 from the X, then that's multiplication between them. But right now, all I'm doing is taking the entire 3X. Okay, how do I do that? Well, what I'm going to do is keep in mind, like I said before, this is the same. If it's a positive term, then it's the same as saying 0 plus that term. Whatever the term is in the front, you can say 0 plus that term if it's positive, or 0 minus that term if it's negative. So if I'm going to undo that plus 3X, to eliminate it, I'm going, or, undo an addition, I'm going to subtract 3X on one side. Now, whatever I do on one side, I have to do on the other side too. But notice I'm going to subtract the 3X from the 5X. Now, why am I going to do that? The reason I'm going to do that is because when you are adding and subtracting terms, they have to be alike. So I cannot add or subtract a 3X from the 4 on this side because they're not like terms, okay? So let's go ahead and do that math for a second. So I have 3X minus 3X, and that's 0. And notice I have a negative 7 that I'm going to bring down, all right? So that negative sign or the subtraction sign in front of the 7, it stays there because I haven't touched it yet, okay? And that is equal to 5X minus 3X is going to be 2X, and then plus 4, all right? Good. So now, still same thing. We're going to keep going through our steps. We want to still get the X by itself. This is how we get unstuck if we get to this place and we're not sure where to go. So how do we do that? Well, I need to get the X by itself, and I see a 2 and I see a 4. See a 2 and a 4, all right? And remember, the 2 is being multiplied by the X and the 4 is being added. So we have multiplication and addition. Now, at this point, we said we're going to undo those operations, but we're going to do PEMDAS in reverse in order to figure out which one of those operations we're going to tackle first. So we have to, if you're doing PEMDAS in reverse, you're going to tackle addition before you do the multiplication. So if I'm going to tackle the addition of 4, how do I undo an addition of 4? Well, I need to subtract 4, all right? So I'm going to subtract 4 from both sides. So subtract 4 from the left-hand side, subtract 4 from the right-hand side as well. All right, so let's do the math. So we have negative 7 minus 4, and that's going to give us a negative 11. and that is equal to, now notice the 2x just stays there. All right, good. Now, our last and final step, we're going to take care of that 2 because remember, our goal is to get to the x. So how do I get rid of the 2? For those of you who might still be saying, I'm going to subtract the 2 because it's a positive 2, the answer is going to be, I'm going to divide by 2. Why? Because the 2 is being multiplied by the x, and the opposite of multiplying by x is to, or multiplying by 2 is to divide by 2. Once again, I'm not dividing by 2x. I'm dividing just by 2 because that's the thing I want to eliminate. So divide by 2, and I'm doing that on both sides. So x is equal to, now if you want to, you can actually, depending on how they ask you to do this, you can leave it as a fraction, negative 11 over 2, or negative 5.5. I'm sorry, my handwriting is a little tiny there. Let me write it a little bit bigger for you to see. So negative 11 over 2 or negative 5.5, depending on how they ask you to write your answer. All right, but both of them work, at least for this example. Let's take a look at this one here. Another example, similar, but still different. You can look and see, can I simplify on either side individually? The answer is no, I cannot. Why? Why can I not simplify them? Well, because on the left-hand side, I have 5x minus 2. The only way I can subtract them is if they're like terms, and they're not. And then on the right-hand side, I have 3x plus 4, and the only way I can add them is if they're like terms, and they are not. So with that being said, let's go to the next step. My goal is to get the x by itself. Well, if I highlight where my x's are, notice that they are not on the same side. So if my goal is to get the x's on the same side, then let's go ahead and move all the x's to the same side. All right, now the terms with the x's to the same side. So let's say I wanted to move the 3x, the entire 3x. Now remember, once again, I'm not separating the 3 from the x at this point. All I'm doing is taking the entire term to the other side, okay? So remember, as we did before, if I have a number in the front, right, and it's positive, it's the same as saying 0 plus that number or that term, okay? So if I'm undoing that, it's going to be minus 3x, all right? And I'm going to do the same thing on both sides, minus 3x. Now notice I'm subtracting the 3x from the 5x, and the reason I'm doing that once again is because they are like terms. I cannot subtract 3x from the 2, the negative 2, because they're not like terms. All right, so 5x minus 3x is 2x. The minus 2 is still there. I didn't touch that yet. 3x minus 3x is 0. And then the 4 is still on the right-hand side. All right, let's keep going. At this point, we still want to get to the x, okay? So what operations do I see? What's in the way? Well, I have a subtraction by 2 and I have a multiplication by 2. Right? So those two things are in the way, and the operations are multiplication and subtraction. And at this point, it says we are going to undo those operations using PEMDAS in reverse. And so if we're doing PEMDAS in reverse, at this point, we are going to tackle subtraction before we tackle multiplication. Now, I'm going to say this one more time. This is when we're dealing with equations. If you're dealing with expressions and you're simplifying expressions, then you're going to do PEMDAS in order. But when it comes to equations, it's a little different at this point when we get to the third step. All right, now we have a subtraction of 2. So to undo a subtraction of 2, we have to add 2. And whatever we do on the left, we have to do on the right. So we add 2 as well. All right. And then here we go. We're going to bring the 2x down because we didn't touch it. Negative 2 plus 2 is 0. And then 4 plus 2 is our 6. And then our last and final step, 2 times x. So the opposite of multiplying by 2 is dividing by 2, right? Because we're trying to get to that x now. All right, so x is equal to 6 divided by 2, which is simply 3. All right, wow. Wow, that was a lot, okay? But we've made it very close to the end. We're almost done, okay? Now, what happens when it looks like this? You know, don't get a heart attack right now, okay? Oh my goodness, this looks so crazy. It's a lot, Ms. Nelson. Well, it can seem that way, but it doesn't have to be overwhelming, okay? But what I'll do is I'll leave this up for homework for you, muscle work. I want you to try it, all right? I want to see your face. My camera turned off for a second. So let me see if I can get it back on for you guys so I can see. Makes me feel like I'm actually looking at your faces. All right, so real quick before we close out, all right? So try this. When we meet on Tuesday at 5 o'clock, I'm going to pick up here, do this question, and then we'll keep moving, all right? So we were able to get through all of that. Single step, multi-step, variables on both sides, equations, all right? Now your study tip. What's your study tip? What am I going to leave with you? Our study tip is this. How do I take effective notes in math? My notes are everywhere. If I'm doing history, it's really easy. Like I can just write down what they're saying. If I'm doing English language, it's pretty straightforward. But with math, how does it work? Well, with math, one of the effective ways that I've found to take notes in math is, first of all, you need to write the topic. Like some of you like, duh. But it's not as straightforward for some people. Okay? So write the topic. The second thing, write the objective or goal. So for example, if the goal is solving two-step equations, that could be the topic as well, that's fine. But write that down very clearly. Why? Because when you get a test question or a homework question that tells you to solve this two-step equation, now you go straight to your book to where it says solving two-step equations. You get what I'm saying? All right? And then you're going to make sure that you write down examples, all right? You can write down 2 to 3 examples, different examples, just like how I was going through different types of examples in our slides. Write down some examples and how they are solved step by step. Now, I don't know how your teacher writes, but for the most part, try to keep the order in which the teacher writes the example, make it as clear as possible for yourself, okay? So you can see everything step by step. So for example, when I did this, let's go to this example here. Notice that everything is literally right under each step is below each other, if that kind of makes sense. So you can kind of see clearly each step for what it is. Make sure you write your steps very clearly so that you can go back and know where your issues are if you have to do some review. And then the other part of it says write the steps to get from the problem to the solution. So for example, every time we did our questions, I showed you the steps on the screen. You had 3 steps. After class, if your teacher does not give you any steps written, go to your teacher and say, okay, if you were to give me 3 steps, now this might sound crazy, like, you shouldn't have to give me all the steps, whatever, okay? Ask your teacher. If they say no, then I'm sorry. Go on YouTube, right? YouTube can be used for more than just foolishness. You can use it to find the steps to help you to solve problems. Once you can find the steps, maybe 3 to 4 steps or 1 or 2 steps, then try to use those same steps consistently to solve certain problems. And then if you get to a place, for example, let's say you go and you try problems that we've done or other problems using the 3 steps I did, and those steps just doesn't get you to the solution, then that might just be a different problem. And then you can say, okay, well, how do I tackle this, right? So some effective tools when it comes to taking notes in math, write the topic and the objective. Make sure you take clear examples down, and also write about 3 to 4 steps, whatever the steps are. I'm saying 3 to 4, but it could be more, it could be less. But try to figure out what are the steps to get from the problem to the solution, and try to practice those steps over and over again. All right, and that's why I kind of went through this whole time giving you the same 3 steps the whole time, right? So once again, I want you to try this example on your own. It's a little bit more complex, but what it does is it integrates the use of that distributive property, combining like terms. So literally you get to use all of the steps that we talked about to solve this question. And we're going to pick it up here the next time we meet, okay? I'm so excited to hear your success stories, and even maybe your stories of how you may have been disappointed here and there, but you're going to be an overcomer. I believe in you, and I hope you believe in yourself more than I believe in you, okay? So we've come to the end of our time together. I'll see you on Tuesday at 5 o'clock. Go ahead and like and subscribe the YouTube channel. Our handle is @ReteachLearning. Okay, you're going to see my face if you're not sure which one it is. And that's going to just help so that whenever I go live, whenever I post a video, when it comes to math or even some learning tips, and for you guys, I know there's some teachers watching. If you want to know, okay, how do I teach this math concept in a way that's understandable and clear? or maybe how can I find a different way to do it. You can find some content there as well as I'm going throughout the new year. So see you later. Bye.